Okay, so we're going to look at an example here, and here we have all the activities listed as well as their preceding activities and their expected completion times. Now, the first thing we're going to do is we're just going to draw the PERT network using the instructions and rules that we have looked at earlier. And we're going to just set up the PERT network. And remember, the PERT network is just a graphical representation of the relationships between the activities in a chronological order. So you can actually see your scheduling and how your scheduling is working. So the first thing we're going to do is we're going to look for all the activities which have no preceding activities. So in this case, it's activity 1, A, and activity B. So they have no preceding activities. So these are the ones that are going to lead from our starting node. So we have to draw our starting node. So let's just go ahead and draw a node over here. And now both A and B are going to exit it. So we're going to have A sitting over here and B sitting over here. The fact that we know it's 2 means we can space it in a reasonable manner so that our graph is not going to look too messy or too cluttered or compacted. And both of those have to have ending nodes. Okay, so those are our ending nodes. So now we have both activity A and activity B on our PERT network. Now what we're going to do is we're going to just go down the list, and if all the preceding activities are already in our graph, then we can draw it. Otherwise, we're going to leave it until all the preceding activities are in our graph. So we're going to look at C now. And C says both A and B are required to precede it. So in this case, we have to create a dummy activity to connect the end of A and the end of B. So the end events of A and the end events of B. So we'll have like a dummy activity sitting in between them like that. And that way, we can now attach C to either one of the end activity of A or the end activity of B, because we are going to be aware that we're going to need both. So I'm just going to point the arrow up, which means that it's going in the direction of, goes from B to here, like that, as well as needing A. But we could have pointed the arrow down as well. Okay, then I'm going to just place C like this with an end activity. And I'm following the approach of let's just draw it and we can neaten it up as we go. So now we have activity C on our graph. And we move on to the next one. So the next one is activity D. Okay, so we have activity D. And activity D requires activity B. So out of the ending event of B, activity D needs to occur. Now, at the moment, I'm going to draw it like this. I'm just going to be like, it would be something like that with D. But when we look at our table, we're going to notice we have no more activities. So technically, we need a situation where we have one end node. So remember our rules said we have one beginning node and one end node. And right now we're sitting with 2 end nodes. So what we can do is we can push this gray D up so that its node is connected with the end of C. So we're going to write it as D, like that. So let's just quickly rub out the rest of it. And let's just finalize this with a white line so that we can see the graph pretty clearly. And there we have our PERT graph. But we're not finished yet because we haven't numbered the events. So remember, when we number the events, we're going to label this one 1. And then we're going to go to the next level. The next level is basically where the nodes of these adjacent vertices are. So you have one edge between them. And this is the next level. So it's these 2. And what we're going to do is we're just going to go in order. So this will be 2 and this will be 3. And then we go to the next level. In this case, there's only 1 left over. So we're going to number it 4. Okay, so that is our PERT network. But now we're also going to start considering bring in the other information for our PERT networks. So we're going to look at the earliest possible event times. So basically, when can they be finished? Or when can the event start? And remember, this is the starting event. This is the event after both A and B. This is the event after just B. And this is the event that takes place after C and D, which means it's the event that takes place right at the end, because you have A and you have B, and then you have C and you have D needs to be finished to get to this fourth event. So let's work out the times associated with that, and we'll discuss how we do it as we go about it. So we are going to have to calculate the start time of the events. So this one is just 0 because it is the official starting time for everything. And we're going to put it in a rectangle. So our rectangle is going to mean the earliest possible event time. And now we're going to work out the earliest possible event times for all of the nodes, so all of the circles. Okay, so we're going to have rectangles over here, and over here. Now, to work out the earliest possible event times, you need all the activities connected to that event, so going into that event, to be finished. So the duration of those events are going to play a huge role. So what we're going to do here is we're just going to update our network a bit by putting in some more information. So A takes 4 days, B takes 3, D takes 4, and C takes 5. So if you're confused on where I'm getting this from, I'm getting it from the table over here. A takes 4 days, B takes 3 days, C takes 5 days, and D takes 4 days. So I'm just putting that information on my graph so that I can use it when I'm doing my working out. And don't forget that my dummy activity, which is this one over here, we just give it a weight of 0. So it takes 0 days. So we're just going to put 0 there. Now we can slowly start working out the earliest possible event time. So if you look at event 3, so let's start with event 3. To get to event 3, activity B needs to be finished. So event 1 needs to be finished and activity B needs to be finished. So what's actually happening here, and let's use a color, we have the 0, the event time. So it's coming from that event there, plus the activity that's going into its duration. And that's going to give us 4. There is no other activity that is going into 3. So 3 is the only one that matters. By the way, my math is awful there. 0 plus 3 is 3. Okay, so let's just fix that. I am terrible at basic math. So again, we have the event start time there, or end time is 0. And this event needs to be finished, and then this activity needs to be done before we can get into 3. So before 3 can start. So we have that 0 plus the 3 gives us the 3. And that's going to be our earliest possible event time. So it's the earliest time that event 3 can begin. So we're going to put 3 down there. So that one was a relatively easy one. Now we have to look at 2. And when you look at 2, you have the situation of A needs to be finished and B needs to be finished, because you can see there it has 2 arrows. So what we're going to do is we're going to focus on just looking at one arrow at a time, so one arc at a time, or link, however you want to look at it. And we're just going to look at the fact that we have the 0 plus the 4, which is coming from A is equal to 4. So we have the event that is connected to, plus the weight of that edge, that arc, or that link, whatever you want to refer to it as. And that is going to give us 4. But there is another arrow going into it. So here you have another arrow. So this arrow weight is 0, but it has to incorporate this event's time. So we actually have, for this edge that's coming into it, 3 plus the 0, which is going to give us 3. So then we're going to look at the two cases. So in this case, it is going, well, the two cases here are 0 plus 4 and 3 plus 3. And we're going to choose the larger of those two cases because both of those have to be finished before event 2 can begin. So we're then going to put down 4. And now we can move on to the next event. So the next event is the 4th event. And we're going to be like, okay, we have to do the same thing we did now, where we evaluate all the events and arcs going into it. So we're going to look at the C because C goes into it. So that's going to be 4 plus 5, which gives us 9. Where's that coming from? Event 2 has an earliest possible event time of 4. And it's almost like an automatic, you can start C the moment, because C event 2 starts and stops like super quick and moves on to activity C. So we have that 4, and we have the 5 coming from the actual duration of activity C. So that's going to give us 4 plus 9. But we also have event D going into it. So we need to investigate what D's time is going to take. So we're going to look at event 3 in that case, because 3 goes into D, and then D goes into 4. So we're going to have 3 plus 4, which gives us 7. And then we'll need to look at both those cases and go, okay, which one is bigger? Because again, event 4 can only begin once both of those are done. So in this case, it is 9. So that time is going to be 9. And let's just put it in the correct color. 9 over there. So now we have our earliest possible event time on our PERT network. Okay, so this graph looks kind of messy right now. So let's just neaten it up and redraw it in a bit. So we're just going to move our page. And we're just going to do a quick rejoin so that we can look at the next concept. So quick rejoin, that's going to be 1. That's going to be A is equal to 4. That's going to be 2. That's going to be B equals to 3. That's going to be 3. We have our dummy activity happening there, and that's 0. Then we're going to have our C equals to 5, and our 4, and our D equals to 4. And then we're going to have our earliest possible event time sitting over here. So that's 0, that's 4, that's 9, and that is 3. And now what we're going to do, we're just going to make this a little bit bigger. So when we work with it, we can look at it quite a little bit easier. And now we're going to look at the situation of the latest allowable event time. So we had the earliest possible event time, but now we're going to investigate the latest possible event time. And we're going to indicate this one with a circle. So the circle is going to indicate the latest allowable event time. Okay, and this one, instead of going from the left-hand side to the right-hand side, is going to go from the right-hand side to the left-hand side. So what we're going to do now is we're going to hide that other one and just focus on this graph. So we are going to start off at the last event. So in this case, it's event 4. And we're going to add a circle over here. Now we're going to want to fill in that circle. So the latest allowable event time wants to maintain the duration using the earliest times, because that way you're not using more resources. So for the last one, the latest allowable event time and the earliest time are going to be the same. So this is just going to sit there and it's going to be 9 as well. Because you want, again, it to finish as quick as possible, and you've just found out that you can, if you following the approach, the quickest time that you can finish this is in 9 days. So your latest allowable event time for 4, so that you maintain your schedule, needs to be 9 as well. Otherwise, you're going past the minimum number of days that you can get this completed in, and that's not a good idea, particularly when you're scheduling events and you want to save money and stuff. Okay, so now we have that 9 that sits there. Now we're going to work backwards and figure out the latest allowable event times for all these events so that we don't stop being on schedule. So what's going to happen is we are going to have to look at the activities and the event times and figure out, what's the leeway between them. So we're going to start off with this 9, and now we're going to work backwards. So we're going to have that 9 minus the 5. So let's write that in. So we're going to have 9 minus 5, and that gives us 4. So that means that we have to, if you want to finish at 9, we have to start event 2 at 4. So there is no massively allowable play here. And the thing is, we can immediately take this 9 minus 5 is equal to 4 because there's only one error coming out of event 2 here. So we only have to look at this error's impact on the latest allowable event time. If we have multiple errors coming out of it, we'll have to do just like we did with the earliest time. We'd have to investigate both ways, or all the ways actually, because we can have more than 2 errors. So let's now follow the root of D. So D comes out of 4 and it comes out of 3. So we're going to investigate 3's time. Now to investigate 3's time, we have one error coming out here, right? But we also have the error over here. So let's first work with this error, with the D is equal to 4 error. And let's go ahead and go, okay, so we have 9 minus 4 gives us 5. Now, you may be, like wanting to just put the 5 in, but you have to remember there is another arrow connected to it. It's this arrow over here. So this arrow over here uses this one's latest allowable event time minus the weight of that arrow. So we're going to have 4 minus 0 is equal to 4. And then what we're going to do is we're going to choose the smaller one. Because remember, we want to see what is the latest time that we can start. So it has to fit to allow both these activities to run out and reach to the 9 and not go over the 9. So we're going to choose the smaller one of them. So the latest allowable event time for event 3 is going to be 4, so that C can still take place and we can still finish at 9. If we chose 5, it would mean 5 plus 0, which is still 5, plus 5, and that would have been 10. So we would have been over the minimum number of days that we could complete this in. And that's obviously an unwanted solution. So again, we choose the smaller one. So when we're doing the earliest time and when we're going from left to right, we choose the biggest one. And when we're going from right to left, so we're going backwards, we choose the smallest one. Right, so let's continue. So we now have event 1 to look at. So for event 1, we have 2 errors coming out of it. So we need to investigate both those errors. Let's start with A is equal to 4. So we're going to have A goes into event 2. So we have the latest allowable event time of event 2 minus the duration of A, and that's going to give us 0. We're also going to look at activity B. So B is equal to 3, but it comes out of event 3. So we're going to have 4 minus 3. And that's going to give us 1. And once again, we choose the smallest of these. So it is going to be 0. Okay, so we're actually not done filling in information on our graph. So let's just do that. What we're going to do is we're now going to add a triangle to the mix. And the triangle is going to represent the event slack time. So it is basically going to be the difference between the latest allowable event time and the earliest time the event can start. So it's the slack between the earliest time it can start and the latest time it can start. Like, what's the play around each event? Like, can you start one a little bit later? Is it allowable versus one where you absolutely cannot start it later? So again, it is the difference between the latest allowable event time minus the earliest event time, which is the circle minus the rectangle. So we're going to go in and fill in all the slack times, and they're just going to be triangles. So we're just going to have triangles above all of them or below all of them. We just put it in here. It's kind of messy at the moment, but this is just give you the concept. And to fill it in, again, it's just the circle minus the rectangle. So we're going to have 9 minus 9. That's going to give us 0. Then we're going to have, again, it's the circle minus the rectangle. So that's going to give us 1 in that one's case, in event 3's case. Then we're going to go to event 2. That's 4 minus 4 or 4 minus 4. That's going to give us 0. And then our last one is 0 as well. Now, what this event slack time is also going to tell us, it's also going to tell us which events are critical. Like, which events have to be finished on time, exactly on time, with no leeway in order for us to finish at the minimum time. So what we're going to do now is we're just going to color in those events so you can just see what I'm talking about. So this has a slack of 0, so let's just color it in. This has the slack of 0, so let's just color it in. And this has a slack of 0, so let's just color it in. Now the activities that connect them, they are going to be our critical activities. And this, what we're creating here, is going to be our critical path. So what we have now is we have the critical activities are A and C. So they cannot be delayed in any way. The moment they're delayed, the entire project is delayed. So they're critical to the finishing of the project on time. Okay, and the critical path is the path, that connects them. It's saying, okay, we have to finish. We have to go from event 1, do activity A, to go to event 2, to do activity C, to get to event 4, which is the end. So that's our critical path. Okay. And we can see that from the slack time. So the slack times there was 0, which meant there was no leeway in starting any of the activities that were connecting all of them. And you could see the activities that were connecting all of them from, the fact that we're going to have only one event exiting and entering the same nodes. So we spoke about that rule in an earlier video where we went through a more complicated setup of the PERT network. So now we've added the information. We added the earliest event time, the latest allowable event time, and the event slack time. And from the event slack time, we could find the critical path or the critical activities to complete our project on time and on schedule. So you're like, okay, why did I do this drawing? Well, this drawing will allow you to structure a relatively simple table, which will tell you when you need to start something, when you need to finish it, or when is it expected finished, as well as the leeway that you can have in those activities. And that table will help you with your scheduling. So this graph gives you the background to set up the table or the schedule for the activities for your project. So let's go ahead and create the schedule table. So the schedule table is going to have 2 more pieces of information on it, and we'll be able to write that information or get that information from this graph. So our table is going to look something like this. So let's just zoom out of this a bit. We still want to be able to see this table so that we can use it. And graph, not table. We are drawing the table now. And we're going to still have the activity. Then we're going to have the time. And then we're going to look at all the starting times. And we're going to look at all the finishing times. Okay, and that's going to be its own column. That's going to be its own column. That's going to be its own column. That's going to go like that, and that's going to go like that. But our starting time is going to be broken into two sections. And so is our finishing time. So we're going to have the early start. Then we're going to have the late start. We're going to have our early finish, and we're going to have our late finish. Now, our early start and our late finish is going to be read directly off our PERT network diagram. So let's just write down our activities. So we have activity A, B, C, and D. Let's also write down their times. So that's 4, that's 3, that is 5, and that is 4. If you're wondering where I'm getting this from, remember we were given the duration of the activities, and it's featuring on our PERT network there as well. So I'm just writing it down into the table, kind of like a repetition of the table that we started off with drawing our PERT diagram with. Now we're going to fill in our early start time. So remember, our rectangle represented our early start time, the earliest possible times we can start our events. So in this situation, we're going to read it from, so say we have A here, we're going to read where it begins, and it begins at event 1. So we're going to look at event 1's earliest start time, and we're going to put it in for activity A, as well as for activity B, because B is also leading from that activity. So we're going to have 0 there and 0 over there. Okay, then we're going to look at C. C is sitting over there on our diagram, right? So it needs to finish 2 to finish. Remember, we went through this. So we're going to look at the early start time of 2, which is 4. It's the rectangle amount, and we're going to fill it in on our table. So that's going to be 4. Okay, then we're going to look at D. So D requires event 3. So what is the early start time of event 3? It is 3, so we're going to fill that in our table. So this is pretty much just the rectangles. The rectangles of the events that are our starting nodes of our activity edges. Okay? And a reminder that when I talk about nodes, I'm talking about circles. And when I'm talking about edges, I'm talking about the line that connects the two circles. Okay, so that's just the rectangle. So we have an activity here. It is the rectangle that sits over there. Okay, next up, we are going to look at the latest allowable event time. So we're going to look at these circles. So let's write that in. We're going to look at these circles over here. It's the last column we're looking at, just by the way. So we're going to look at the latest allowable event time, so the finishing times of it, and it is these circles. And in this situation, again, we're going to have our nodes like that and our activities like that, with an activity sitting over here that we're going to look at. But we're going to look at the circle of the activity over there. Okay, so once again, let's actually make this color coordinated completely. If we want to find our early start times, this is the activity that we're interested in. We look at this rectangle. If we want to look at our latest finishing times, so this column over here, this is our activity. It's this circle width that we're going to investigate. So this node circle. So let's go ahead and fill in our information. So for activity A is over there. It's this circle, and this circle is 4. So let's put it in. And then let's go to activity B. So this is activity B. So it's this circle we're interested in, and this circle is 4. So let's go and write that in. Then we're going to look at activity C. And activity C, it's this circle, and this circle is 9. And then we're going to look at activity D. So this is activity D. It's this circle we're interested in, and this circle is 9. So we're going to put that in. So now we've read everything that we can pretty much read on our graph. But actually not quite, because you may be wondering, hey, but what about the slack times? So we have those triangles appearing. So now we're going to look at the latest start time. So this column over here. So the latest start time. So for the latest start time, we are going to look at the earliest start time. Okay. And then we are going to investigate the difference between the earliest start time and when the event is going to finish. Okay, so it needs to finish at 9. So we're going to go through the process. So how is this going to look? Let's actually show it on a diagram. So we're going to have the nodes, the activity, its earliest start time over there, as well as the earliest or the latest start time of the event over there. Okay, so let's go and work out for each case. So we're going to start off with activity A. So activity A sits over there, and we have our earliest start time, which is the 0 over here. And we know our activity is going to take 4. So it's going to need to start event 2. Its latest start time is at 4. So we're basically going to be like the 4 minus the activity's time. So when we work this out, and let's write this in a color here, we are going to take the circle minus the activity time to give us the late start time. So in this case, it's 4 minus 4. So it is going to give us 0. Okay, let's go to activity B. So activity B's latest start time is 4. 4 minus 3 is going to give us 1. So this one is going to be 1. So you can actually see we've already worked this out on our diagram when we're working out the latest allowable event times. We just didn't necessarily use that information. So you notice it sits there and the 0 sits there. So those are already kind of like worked out for you. So you can see the equations that we use. But it's basically the circle minus the activity gives us the late start time. Okay, so now we're going to continue. We're going to look at C. So here is C. The latest start time of the event that sits on this side is 9. Now we're going to have 9 minus 5, and that's going to give us 4. So that's going to be 4. And let's look at D. So the latest start time is 9. 9 minus 4 gives us 5. So this one is going to be 5. So once again, just a reminder, it's the circle minus the activity is equal to the late start time, where the circle is on this side. Let's color it in to just keep it color coordinated here. So it's that circle and that activity. Right, now we have the earliest finishing time. The earliest finishing time is very similar to how we work out the late start time, except now we are going to look at the rectangle and we're going to add the activity to it. So it's going to be the rectangle plus the activity, and that's going to give us the earliest finishing time. So let's go do A. So A is 0 plus 4. That's going to give us 4. So let's fill that in. Then let's go do B. So we have B sits over here. So it's going to be the 0 that's over here plus 3. And that's going to give us 3. Right. So let's go and fill that in. Then we are going to go and look at C. So C sits over here. So we're going to have the 4 plus the C, which is 5, and it's going to give us 9. So once again, in case you got lost, this is C. We take the circle that goes in front of it, or the rectangle that goes in front of it, my bad, plus the 5, which is the C's activity, and that's going to give us the earliest finishing time. So again, it's the rectangle plus the activity gives us the earliest finishing time, where our activity is this here. It's this rectangle that sits there. Okay, now let's do D. So D is this over here. We're going to have 4 and not 4. We're going to have 3. That was a very bad calculation on my part. Once again, it's the rectangle we're looking at. Looking at the earliest start time. We're taking the earliest start time and we're adding the duration of the activity to give us the earliest finishing time of that activity. So we're going to have the 3 plus the 4 gives us 7. And now we have our entire schedule table. So once again, just a quick work through of everything. Our earliest start time, that's the rectangle that comes before the activity. So it's the event rectangle before the activity. We have our late finishing time. Our late finishing time is we have our activity. It's the circle that ends the activity, and it's the circle on top of that event. Then we have our late start time. And our late start time is basically we have our activity that sits there. We take the circle that ends the activity and we minus the activity's duration to get the late start time. Then we look at the early finishing time. And the early finishing time is we have, again, the activity sits there like that. We take its rectangle and we add the activity's duration to it to get the early finishing time. And that gives us our final schedule table. And we can also read our activity slack times off this table by looking at the last 2 columns. So if we look at these over here, we can work out what the slack time is by subtracting the 2 of them. Okay, so in this case, we'd have 4 minus 4 gives us 0. We'll have 4 minus 3 gives us 1. We'll have 9 minus 9 gives us 0. And 9 minus 7 gives us 2. So we have each activity's slack time. So let's just add that to our table. So what we're going to do is we're just going to move our screen a bit. And we're going to add the activity slack. And again, it's the LF minus the EF. So that's going to give us 0, that's going to give us 1, that's going to give us 0, and that's going to give us 2. So now we have slack times for the individual activities, not just the events. And then we have all the information that we need for the project planning. So let's just zoom out a bit so you can see everything that we've done. So a reminder, we started with a basic table about the activities, the preceding activities, and the completion times. We created the PERT network, which is the situation where we have events indicating the starting and finishing of activities. And we drew that. Then we added the earliest possible event time. So remember, with the earliest possible event time, we went from left to right, and we looked at the situation of the largest value is the one that we put into our rectangle. Then we looked at the latest allowable event time, which is going from right to left. And in that case, we looked at the smallest value to go into our circle. Then we looked at the event slack times. So the slack times are the individual events that indicate the starting and finishing of activities. And that was taking the latest allowable event time minus the earliest possible event time. So that's that TL minus the TE, or the circle minus the rectangle. And we filled in the slack times using triangles. Okay, so we could read a lot of information from that diagram, but we also set up the schedule table. So the schedule table took some of that information to fill in our table. So we took the earliest possible event time, the ES, and we filled it in. And again, when we filled in the ES, we had our activity sits over there with the two nodes, and the node before it, the event before it, the starting event. So rectangle is what went into the early start time. Then we looked at the finishing time. So we have an activity chilling over here. We have the event that ends it, and its circle is our latest finishing times. Then we filled in our latest start times. So again, we had this case of we have the activity chilling there, and we have the starting event and the ending event. Our latest start time was taking the latest allowable event time of the ending event of that activity, minus the activity's duration, and that gave us our late start time. So it's this equation over here. So we filled that in. And then we filled in our latest finishing time. So our earliest finishing time, our earliest finishing time. So our earliest finishing time, again, we looked at the activity, and in this case, we looked at the starting events, rectangle. So the earliest possible event time of the starting event of that activity, and we added the activity's duration to it, and that gave us our early finishing time for that activity. So here we have our early finishing times of those activities. Then we could also look and determine our individual activity slacks. So that is just our late finishing time and our early finishing time. And we said our late finishing time minus our early finishing time. So here we had 4 minus 4, 4 minus 3, 9 minus 9, and 9 minus 7. And that gave us a 0, 1, 0, 2. So that's the entire structure for the quick looking at PERT and analysis. There is further information, but this is just for the setting up for this example and as far as we go in this particular playlist. Finishing time.